All right, so we start with, this is all trig related. It started trig, it ended polar, okay? So unit 3 started literally with SOHCAHTOA, right? We know this hopefully pretty well by now. Our sine is opposite over hypotenuse. Our cosine is adjacent over hypotenuse. And our tan is opposite over adjacent. And then we introduced our reciprocal functions. Cosecant, which is hypotenuse over opposite. Secant, which is hypotenuse over adjacent. And cotangent, which is adjacent over opposite. Then we went back to unit circle, and we talked about the fact that, one, everything's in radians. Okay, so in Algebra 2 honors, we did degrees in radians. In Algebra 2 honors, you did coterminal angles, like something like 17 pi over 6 could pop up, but most of the angles on your, anything that's been on a practice is only from your natural unit circle, which means from 0 to 2 pi, okay? So if you can know your unit circle, 0 to 2 pi, all the radians and all the coordinate points and what that means, then you should be good to go. So I would just map out, let's start quadrant angles. On the right is 0, on the top is pi over 2, on the left is pi, on the bottom is 3 pi over 2, and it doubles back around to 2 pi. And then in every quadrant, it's divided into 3 angles. You're over 6, you're over 4, you're over 3. Over 6 is the first one because it's closest to your x-axis. Then over 4, and then over 3. And then we went over tricks, right? In the second quadrant, what's the trick to knowing your numerator? Good. It is 1 less. In the third quadrant, it is 1 more. And in the fourth quadrant, it's 1 less than double. So this would be, you're over 6, again, closest to the x-axis. You're over 4 in between. And you're over 3, closest to the y-axis. God bless you. So this would be 2 pi over 3 because it's 1 less. 3 pi over 4, 5 pi over 6. 7 pi over 6, 5 pi over 4, 4 pi over 3 because it's 1 more. And then 5 pi over 3, 7 pi over 4, and 11 pi over 6 because it's 1 less than double. And then let's start your quadrant angles. Your coordinate points on the right would be 1, 0 because you're going to the right one. At the top, 0, 1. On the left, -1, 0. And on the bottom, 0, -1. Every over 6 has the coordinate point, which is root 3 over 2 and 1/2. Every over 4 has the coordinate point, root 2 over 2 and root 2 over 2. And every over 3 has 1/2 and root 3 over 2. And I could keep going all the way around, or I could know all students take calculus, which is going to change your signs, right? In the first quadrant, everything's positive. In the second quadrant, sine, which is the y, is positive. The x is negative. In the third quadrant, they're both negative. And in the fourth quadrant, the x is positive and the y is negative. And then we even went a step further and talked about our tangents, right? Instead of having to do y over x every time. The tangent on the right and the left is 0 because 0 over -1 would be 0. On the top, it's undefined. On the bottom, it's undefined. Every over 6 tangent is root 3 over 3. Every over 4 tangent is 1. And every over 3 tangent is root 3. The only thing that changes is its sign, positive or negative. Kimar, you getting all this? You getting all this? I'm not going back to it later. Questions on unit circle, because obviously now there's the application of it. This is something that if you, especially during your multiple choice parts, you do have time probably to write stuff down if you wanted to draw it out when you're taking your AP exam. But obviously the goal would be just to understand it enough to have to not draw that all the way out. Okay? Yeah.
Which one's 30, 45, 60?
Well, but there's nothing in degrees on your test.
So we don't have to know.
You don't have to, but 30 would be pi over 6. 30, 45, and 60. Think about your angles are small, getting bigger, getting bigger.
I don't need it.
You do not, your test is in radians. Yep. All right, so then if r equals 1, your cosine is your x, your sine is your y, your tan is your y over your x. Your secant would be 1 over x, your cosecant would be 1 over y, and your cotangent would be x over y. That is on your natural unit circle. So the unit circle has a radius of 1. If r is not equal to 1, so like if you have a graph and it says your radius is blank, or in your text it says r equals whatever and it's not 1, then your cosine is your x over your r, your sine is your y over your r, your tangent is still your y over your x. So your tangent goes unaffected because it's opposite over adjacent. Your secant would be r, well, you'd still flip it, but r over x, cosecant r over y, and cotangent x over y. So you have to account for a radius not being 1, if that's the case. In the word problems, they talk about things like vertical and horizontal displacement, okay? Vertical displacement is your sine. Horizontal displacement is your cosine. So again, you have to pay attention to, is the radius 1? If the radius is 1, then your vertical displacement is just y, and your horizontal displacement is just cosine. So it's just x. But if it has a radius that is not 1, then you have to put it over it. All right, then we went into sine and cosine curves. So not only do we have to understand the graphs of these, but this is where your guaranteed FRQ came from, right? Your sinusoidal stuff. So in your sine and cosine curves, so let's say we've got f of x equals, it would be a sine b x minus, actually x plus c is usually the case, plus d. Or f of x equals a cosine b x plus c plus d. And I would say that that's where it got confusing, because in every other function, the inside was x minus, but in the sine and cosine functions, it gives it to you as plus. It still works the same way. If it was a minus c, you're still going to the right. If it's a plus c, you're going to the left. But the actual equation itself says plus. Your sine curve starts at 0, 0. Goes up to the amplitude, back down to 0, down to the negative amplitude, back up to 0. The full width of that, so from start to finish, is the period, and the period is 2 pi over b. If I wanted to find my key points, I would take my period and multiply it times a fourth times a half and 3/4. So the first one without a phase shift, the first one's at 0. And then this would be your quarter point, 1/4 times the period. This would be your halfway point, 1/2 times the period. This would be your 3/4 point, 3/4 times the period. That's, again, if it didn't have a phase shift. This would be 0, and this would be the period. If I'm looking at cosine, it starts at the amplitude. It comes down to 0, negative amplitude, up to 0, up to positive amplitude. Again, period is also 2 pi over b. And again, those key points are your 0, quarter, half, 3/4, period. Okay, then we had things like amplitude, midline, period, frequency, all that stuff, right? So your midline is max plus min divided by 2. It is also your value for D. That is your vertical shift. Your amplitude is max minus min divided by 2. And this is your A. Well, it's really the absolute value of your A. Because if A is negative, it just flips it upside down. We already talked about the period is 2 pi over B. And the frequency is the reciprocal of the period, or B over 2 pi. Amplitude is, yeah, max. I was saying min. Max minus min. So when we got to the real world stuff, right, there was always something that would give you the highest point, the lowest point, and that gives you your amplitude and your midline. And then there was always something that gave you a start point and an end point, or a start point and a half point, something along those lines that gives you your period. And then you can get B. So if the period is 2 pi over B, then you can also get B by doing 2 pi over the period. So when you're trying to find the equation, the midline gives you D, the amplitude gives you A, and then the period, if you did 2 pi over that, it gives you your B. And then you're looking for a start point, that's your C. So if it says, if you're talking about sine and it says it's at 0 or at the middle point, whatever that midline is, if you're at that point when T equals this, then that's where your C is. If it says something about max height or minimum height, now you can equate it to cosine. And again, it would tell that's your start point. This is where your guaranteed FRQ comes from. This is FRQ number 3, okay, which is the first non-calc FRQ. Yeah.
Wait.
Hang on.
For amplitude max minus min over 2, it can't be negative.
Amplitude itself is not negative, but the A can be negative depending on the direction of your curve.
It's only for the reflection.
Correct. Yep. So then if it said negative 2 sine x minus 3 plus 4, let's just say it says something like this. A is 2. No, A is negative 2. Amplitude is 2.
It's 2.
Correct. The A carries the sign, the amplitude does not. What was your question, Izzy?
What do each of the letters, like A is the
A is A by the absolute value of A is your amplitude, right? So if I do that, right, A is, if it's positive or negative, still a reflection. So negative is a reflection. Absolute value of A is your amplitude. B is going to affect your period. So B is a horizontal dilation, but it changes the period. Because 2 pi over that gives you your period. So it doesn't typically ask you for dilations on sine curves, but let's say it did, it would be a horizontal dilation by a factor of 1 over B, just like everything else. C shifts your start place, right? So this is called a phase shift, but it's also a horizontal shift. Positive C to the left, negative C to the right. Same as always. And then D is your vertical shift. And your midline. And Y equals D is your midline. Because it has to be an equation. We'll come back to these two tomorrow when we do secant and cosecant. We'll do a refresher on it too because obviously it's built on it. All right, and then the last thing on this page is your regression. Remember, when you run a regression, it's only sine. Okay, there's only a sine regression. But it's same thing. It could give you data and ask you to run a regression, okay, from a T-chart, from coordinate points, anything like that.
So if it looks like a cosine graph, that means there was a shift.
correct. Good?
Wait, what did she say?
She said if it looks like a cosine, but I'm running a regression, then it means it's a cosine that was shifted, right? Because this, like, let's just say my regression, when I run it, it looks like this, but I can only run a sine. So that means it's going to either start here and go to here, or it's going to start back here and go to there. There will be some sort of a horizontal shift. Yep. All right, we're going to do the second part. Well, there's more.